Trigonometry. Trigonometry. We want to look at trigonometry. In particular, we're going to look at right-angled triangle trigonometry. So, what is a right-angled triangle? A right-angled triangle is a triangle with an angle of 90 degrees. So, this little square in the corner shows you the 90 degrees there. So, any triangle with an angle of 90 degrees is a right-angled triangle. Now, for every right-angled triangle, the side that's opposite the right angle, or the side that's opposite the 90 degrees, is the longest side of that triangle. So this side here is the longest side of this triangle. The longest side of a right-angled triangle is known as the hypotenuse. The hypotenuse, right? So we've identified one side. If I call one of the two remaining angles, theta. So if I pick this one and I call this angle theta, theta is just a Greek letter that we use, right, to identify an angle here. So if I call this angle theta, then the other two sides can be named depending on their relationship to theta. If I look at this side here, this side is opposite theta. So we call this the opposite. This side is next to theta or adjacent to theta. So we call this the adjacent. So now, when you have your right-angled triangle, you are able to identify three sides: the hypotenuse, the opposite, and the adjacent. So the adjacent and the opposite depend on the angle you're looking at. Okay, so for example, if we had a triangle much the same, but we were going to make that our theta, this is still our hypotenuse, the longest side, right? Now, this side is opposite theta. You can see this side is now the one that's opposite theta. So we call this one the opposite. And this one is now next to theta, so we call this one this adjacent. Okay, so that's the adjacent side to theta. Okay, now let's proceed to what we call trigonometric functions. Trigonometric functions. Okay, so what is a trigonometric function? A trigonometric function forms a relationship between the angle and the sides of a right-angled triangle, right? So if we have an angle theta, right? And then we've got the sides, maybe the opposite, the adjacent, and the hypotenuse, right? If we have a relationship that's formed between these things, we form it using a trigonometric function. So a trigonometric function will form a relationship between theta and the opposite, adjacent, hypotenuse in different combinations there. Now, what kind of relationship are we talking about, right? In mathematics, the relationship we commonly, what we call relationships is commonly an equation, right? So really what's going to be formed is an equation that involves theta and any two of these, right? It could be theta, opposite and adjacent, it could be theta, adjacent and hypotenuse, or it could be theta, opposite and hypotenuse, right? So let's look at our trigonometric functions. So there's three main trigonometric functions. We have the sine function, we have the tangent function, and then we've got the cosine function. So we've got the three trigonometric functions: the sine, the tangent, the cosine. Now, here are our relationships. Sine of theta is equal to opposite over hypotenuse. Tan of theta is equal to opposite over adjacent. And cosine of theta is equal to adjacent over hypotenuse, right? Sine of theta is opposite over hypotenuse, tan of theta is opposite over adjacent, and then cos of theta is adjacent over hypotenuse. Now, people may have trouble remembering these relationships, right? So that's why you have the mnemonic SOHCAHTOA, right? So what does this mean? Sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. So it's a simple way of remembering those three relationships between the angle and the sides. Okay, so now let's put this into practice. Let's see how we actually make use of these trigonometric functions. Let's have an example. Got a triangle here with an angle of 30 degrees. Then we've got an hypotenuse of 18 centimeters. Then we've got this side x. And you're asked to find the size of x. Okay, so the first thing you want to do is to identify the sides, right? In other words, you want to name the sides, the opposite, the adjacent, and the hypotenuse, right? So what do? Try another color there, right? The longest side is 18. It's opposite the 90-degree angle. So this is the hypotenuse. And when you look at your angle is here. So x is the side that's opposite, right? And then this is the adjacent, okay? So the information we have in the question is 18 and x. The information is given on the hypotenuse and the information is given on the opposite, okay? So what we know from our question, we have information on the opposite and the hypotenuse, right? So if we remember, SOHCAHTOA, we want to look for a relationship that relates opposite and hypotenuse, right? Here it's opposite and adjacent, so we don't want this one. Here it's adjacent and hypotenuse, so we don't want this one. Here it's opposite and hypotenuse, so this is the one that we want. We want the relationship presented to us by this sine function, right? So if we write it here, sine of theta is equal to opposite over hypotenuse, right? In this case, our theta is 30 degrees, so sine of 30 is equal to the opposite, which is x, over the hypotenuse, which is 18. So this is a simple equation. Sine 30 is equal to x over 18. If we want to find x, we have to multiply both sides by 18. So we want to remove 18 from the denominator. So we have 18 sine 30 is equal to x. So you can submit this to your calculator. Just type that in, 18 sine 30. 18 sine 30 gives you 9 centimeters. So the length of side x is 9 centimeters. So let's try another example. Start off with the blue again. Okay, so let's say we have a triangle inverted differently like that. And then perhaps we have our angle here, which is 60 degrees. And then just looking for some simpler angles here. And then we have our y, and then we have our 14 meters. And then we're meant to find the length of y. So the same procedure follows, right? We follow the same procedure. We go through the same steps. We have to identify the sides, right? We have to know which one is our opposite, which one is our adjacent, which one is our hypotenuse, right? The longest side is opposite the 90-degree angle, so this is the hypotenuse. This side is the opposite, it's far away from this angle, 60, and this one is next to the angle, so this one is the adjacent. The information we're given in the question is on the hypotenuse and on the adjacent, right? So we want a function that's going to link or form a relationship between adjacent and hypotenuse. So if we have saw, car, toe, we know that this is opposite and hypotenuse, so we don't want that. That one is opposite and adjacent, so we don't want that. Adjacent and hypotenuse, that's what we want. So in this case, we're going for the cosine function, okay? So we quote it. Cos of theta is equal to adjacent over hypotenuse, right? So cos of 60 is equal to adjacent y over hypotenuse 14. Now this is a simple equation again. If you want to find your y, you have to multiply both sides by 14. So 14 cos 60 is equal to y, which gives you 7 meters equal to y there. Okay, so this is simply how you can make use of the trigonometric functions to find a side that is anonymous. So you can try a few questions, then we go to the next section where we're finding angles.